Good afternoon, everyone. Let's get started. First, I would like to give you a short advertisement. There are some AI Graduate School events. The first one is casual lunch. I told you about this. We have 4 casual lunches throughout the year. And you could talk about casual things with AI Graduate School faculties. And there is Open Lab. Another event is Open Lab. It is going to be held at 1:30 p.m. April 7th. Actually, this is on this Friday. It's on this Friday. And it is going to be at AI Studio or AI TED Hall. It's going to be in the building at 7. You could talk about academical things with current MS and PhD students. And you can also talk about research projects going on in each lab. And you can talk about research opportunities like interns or graduate studies and etc. And if you follow this link, you can sign up for the GIST AI Graduate School Open Lab. You can click this apply or join. If you're interested, please click this link. Another thing is, so by the way, are there any questions regarding AI Graduate School events? Okay, let's move on. Homework 4 is due on Thursday, and homework 5 will be out on Thursday. So homework 5 is going to be the last homework before midterm. And regarding midterm, it is going to be on April 18th from 1 p.m. to 3 p.m. And the exam rooms are going to be GIST College Building C. And we have 2 rooms because we have so many students, room 104 and room 109. I'll let you know which room you need to go next week. And the midterm coverage is from Python primer to binary search that we are going to talk about next class. And you need to have a look at lecture slides, the code I gave you, and homework problems. And the midterm problem formats are 3 types. And I'm going to make 7 to 10 problems. I haven't yet made the problems. The first type of problems is WWPP, what would Python print? And PPP exercises. So it's going to be just general coding problems and short answer questions. And you can refer to the last year's midterm. You can go to the website. And it is closed book, closed laptop. So just bring your pen and eraser. That's all you need. Do not bring any books or laptops. And on April 11th, I'm going to do a midterm review. However, it is like Q&A session. It is an optional, and it's going to be face-to-face. So you can come to the lecture room. And you can choose to attend the class or not. It is totally optional. If you have no questions, you don't have to come. And I will accept questions in Korean and answer in Korean if you ask in Korean regarding lecture materials. And regarding homework problems, you can attend TA office hours or recitations. So regarding midterm, are there any questions? Last year's exam can be retrieved from last year's course website. So, you know, this one is slow now. And I'm going to record midterm review. And you can use any pens. If you do not have pen and eraser, but if you prefer in Korean ballpen and white, that's okay. This is our course website. If you click this one, and last year's website is this one. And here you can have a look at the last year's midterm solution. So you can check this out. This one is last year's problem and solution. So you can have a look at this. Any other questions regarding midterm or midterm review or any other things regarding course? Okay, let's move on. And after midterm, I'm going to try this new style of lecture. From April 25th to May 4th, I'm going to just upload the lecture video with PPP exercises. So the format is going to be something like this. So I'm going to just upload this Colab with these videos. So you can just watch this concept video. And the left one is going to be English and the right one is going to be in Korean. And you just watch these videos on your own and do these PPP exercises. I'm thinking of this new format because some students say they need more time for PPP exercises. And sometimes they need to go back to the lecture video and to understand the concepts fully. So I'm thinking of making this kind of lecture materials for you. So you can do it on your own pace. You don't have to rush. And on Tuesday, you are going to ask questions online. You can leave comments below each video, then I'll answer. And on Thursday, I'm going to accept questions face-to-face. We're going to gather at room 104. And if this is going to be fully online, then the attendance matters. So you just need to submit a copy of your work. So I will upload this Colab and you watch these lecture videos and then do your PPP exercises. And there are going to be other videos and do PPP exercises. And then you share this Colab as your attendance. So that is what we are going to do after midterm. So I'm going to do this for like 2 weeks. And then I'll do a survey to check which one is more effective, like the current online live lecture or the new format. So you study basically independently, and I'm going to hold QA sessions, face-to-face QA sessions once a week. And this is to improve the effectiveness of lectures. So if you have any ideas to improve the effectiveness of this lecture or this course, don't hesitate to contact me. About new lecture format trial, are there any questions? Okay, that was quite long course logistics. Let's move on to today's lecture. Today we are going to talk about cues. But before we do that, let's talk about last class's PPP exercise. So in the last class, we talked about reverse Polish notation for mathematical expressions. In this case, we put operands first and then operator. So this equation becomes 3(1) plus 4 times. In this case, how do we evaluate this RPN, reverse Polish notation? We get the first 2 operands and then operator. And we evaluate this expression, 3 plus 1, and then put this value in front like this. And then we retrieve 2 operands like this, and then 1 operator. Then we evaluate these 3 expression, and then we put this value again into this stack. So we can basically implement this eval RPN using stacks. Let's implement this together. So what we are going to do is, first we are going to define a stack like this. And for each token, in tokens given, we just need to check whether what we retrieve is operand or operator. So if this token is in operations, what we are going to do is retrieve some values, operands from this stack, like this. And then after we do this, we're going to evaluate this value expression using the operation we retrieved. So that's what we are going to do. Otherwise, we are going to push this token into our stack. And here, I just wanted to check whether this token, the current token, is an operator or not. So I'm going to define an operation as dictionary. And there are going to be 4 basic operations. The first one is plus, and the second one is minus. And the third one is times. And the fourth one is division. And because we want this to be just operator, I'm going to define a lambda function. So this one receives 2 numbers and conducts this operation, a plus b. Lambda, okay. So this one will be just minus, and this one will be just times, and this one will be just dividing. So if you just implement this, it will work perfectly. And after evaluating all these operations, we are going to just return the thing in the stack, which is going to be the result of evaluating this reverse Polish notation. So this is the solution of this EVA RPN function. Any questions regarding this implementation? Okay, let's move on. Today's topic is queue. So what is a queue? You can think of a queue as people lining for something. So basically queue is first come, first serve. You first come, you go out first. And the last come receives the service for the last time, at the last time. So basically, the first item that comes into this queue will get out of this queue for the first time. And the last item that came into this queue will get out of this queue at the last time. So that is basically what a queue is. Formally, a queue stores a collection of elements. We've been talking about various types of collections of elements. However, they treat elements in a different way. And a queue behaves as a queue of people lining up for something, where you can only access to the first element. And this one works on the principle of first in, first out, FIFO or FIFO. And QADT, the functionality of a queue, is constructor front. This one returns the elements at the front of the queue. And in queue pushes an element into the queue. And this element is going to be the last element in the queue. And we need to be able to retrieve some item from the queue. So that is going to be done by DQ. And you don't have to pass any arguments here because the first item or the front item is going to be retrieved. IsEmpty function method returns true if there are no elements in the queue. And As you can see here, queues and stacks are quite similar. And let's contrast queues and stacks. Basically, queues follow the principle of first in, first out. And stacks follow the principle of last in, first out. So the last item becomes the top item and it gets out of the stacks for the first time. However, on the other hand, queues, first item gets out of the queues for the first time. And when you push some new items into the storage, stacks uses the terminology of push, whereas queues uses the terminology of in-queue. And queues uses the terminology of dequeue, whereas stacks pop. And in the case of queues, it keeps track of first and last items. However, in the case of stacks, it just keeps track of just the top item. And there are many applications of queues. First of all, emails is queued, and graphical user interfaces depend upon event queues. So if you click this graphical first and then user second, then the first click will be handled first. And then the second event will be handled the next time. So graphical user interfaces depend upon event queues. And documents sent to the printer are spooled. Spooled means queues. Sometimes you might have seen the spooling error from your printer. That is because the queue is mixed up. And data transferred to a stream are buffered. And buffer means the data you sent is queued. So the first thing you sent will get to the point for the first time. And machine instructions are executed using a sophisticated queue known as a pipeline. We're going to see this concept in computer architecture or computer systems courses. Okay, let's implement queues. By the way, queue itself is also very straightforward and easy to understand. Therefore, we are going to focus on applications of queues. Before we start implementing queue, let's define some errors first. We need to check whether queue is empty or not, or full or not. And as we did in stacks, we can implement queues. Implementing queues using different ideas. The first idea is using Python lists. So this is the basic idea. Python lists makes life very simple. You can implement queue using Python list. That is going to be just keep track of all the items inside this queue using a Python list. And you can additionally keep track of the size of this queue. And implementing this easy empty method is also very easy. You just need to return whether the length of the internal list is 0 or not. Otherwise, you can just return whether the self size is 0 or not. All right. And we talked about this front method. It returns the front item. However, if this queue is empty, then we cannot return the front item. In this case, we're going to raise empty queue error. Otherwise, we're going to return the item at the front. And dequeue is going to be if the current queue is empty, then we just need to raise empty queue error because we cannot dequeue anything. Otherwise, we are going to decrease the size by 1. And then we are going to return the item at the front. However, this operation takes O n. Internally, Python list takes O n to access to the first item. And we talked about this in linked list class. And when it comes to enqueue, we need to pass an item to store. That is very simple. We are going to just append this item to the internal list. And when we do this, we are going to increase size by 1. In size method, just return self.size. Okay, so this is our basic queue. And we can test our queue, creating this queue. So first, we are going to check whether isEmpty is working perfectly or not. And we are going to add some items to this enqueue. And we can enqueue more items like this. We can check the functionality of this front method. And we can dequeue some items like this. And when we run this, when we first init, it says it is empty. And after enqueuing 1, it says it's not empty. And front of the queue becomes 1, 2, 3. The first item get into the queue becomes the first front. And after dequeuing, the first item gets out of this queue. And the second item becomes the next front. And third, the next time. All right, so this is how we implement queue class using Python list. However, as I told you, this dequeue operation takes O n times. So it's not very efficient. And we are going to make this more efficient. How can you do that? The basic idea is so let's improve this implementation. The basic idea of implementing more efficient queue is using 2 lists. So the first one is going to be called in, and the second one is going to be called out in this way. And what we are going to do is, so isEmpty is going to be whether this in and out are both 0, then it means the queue is empty. In the front, then we are going to define a special function, special method that is going to be sorted out. If self is empty, it's going to raise empty queue error. Otherwise, what it's going to do is, if the self out does not contain any item, it's going to copy all the items inside this in, and we are going to reinitialize this in list as an empty list. And we are going to reverse the order of the out list. So that's what we are going to do. And when we try to get the first item, what we are going to do is first, we are going to sort out. Sorry for that. What we are going to do is we are going to just return the item, last item. Because the order is reversed, the last item is actually the first item. And when we want to dequeue some item, what we are going to do is we are going to sort out first and going to return the item in the out list and get the last item just using pop. So this is what we are going to do. And when we try to enqueue a new item, it's going to be just appending a new item at the end of the in list. So in this way, we can improve the efficiency of queue implementation. This one, because we are just taking the last item from this list, it takes O1. So basically, this class takes O1 on average, and this is much better than this implementation, which took ON. Any questions up to this efficient implementation? Some might say that this one is basically just copying the in list to out list, and then we need to do reverse operation. And is it really efficient? So you need to be careful about this term, on average. So this operation is on average ON. However, the worst case is going to be ON. So we do not dequeue in the middle. However, we just enqueue all the times and then dequeue all the times. Then it's going to take ON because it takes much longer time than this. And we can check whether our improved version is working perfectly or not using this test code. Sort out. This should be sorted out. So it works perfectly as before. So this is the second implementation. And so up to this point, we've been looking at implementing queues using Python lists, and we improved the efficiency using two lists. However, as we did in stacks, we might not have Python lists when we are using different languages or we are in different development environment. In that case, we need to use arrays to implement queues. So how can you implement queues using arrays? The basic idea, so I'll first define the initializer. When it comes to implementing queues using arrays, we need to define a list with a specific amount of memory space. So here we are assuming that we cannot change the length of the array. So this is a part of init method. And the basic idea is like this. In the case of initialization, let's say we have a length of 5 list. And the basic idea how we are going to tackle this problem is we are going to use front and rear pointers. And after we insert some item, what we are going to do is, as we insert new item, let's say 1 is inserted, then we are going to move this rear pointer to the next point, okay? And we can add more items. Insert more items. And it's going to move to the next point. And the next thing we can do is, when we DQ, some item, we are going to move this front pointer to the next point. And we can replace this one as none or not. However, let's just say it's N. So in this way, we can move our front and rear pointers. So when we are trying to include some new item, we can put that item where the rear pointer is pointing here. And when we are DQing some item, we get the front item from where this front pointer is pointing at. Okay? And here you might be wondering, what if front and rear point to the same point, same position? So does it mean full queue or empty queue? So because this ambiguity can arise, what we are going to do is we never allow front and rear coincide. So even though we have 5 spots here, because we do not allow front and rear have the same position, we can actually use 4 spaces. So we always keep 1 slot free. So that's how we handle this problem. And it is also called circular queue, because after adding more items, the rear can be at the front, like this. However, front can be later than rear pointer. So this could happen. So they turn around this queue. So this one moves here, 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 and then it goes back to the first point and then move to the end like this. Rear pointer does the same thing. So in this way, we can use the space efficiently. So can you guys understand what this circular queue is about? Any questions regarding this concept? Cool. So I'll just give you the full implementation of this init method. So at the first time, the front and rear point to the same position like this. And we need to implement isEmpty method, isFull method, and front method, DQ method, and InQ method. So this is going to be today's first PPP exercise. Try to implement these 5 methods. And before you tackle this problem, please send me PPP message. By the way, if you have any questions, you can ask away. I'll give you 1 more minute. Okay, thank you for sharing your answers. This might take more time than 10 minutes that I gave you. Anyway, let's do this together. When you try to implement is-empty method, you just need to check whether the front and the rear is pointing to the same position. That's what you need to do. So the empty case is this case when we initialize this Q. And when is this Q is full? That happens when rear is at this point. And when we try to enqueue some item, we access to the rear position. And if the next item, the next position after rear is front, that means we cannot add more item here. Because I told you that we are going to keep one space empty. So that's how we are going to do. So is empty is by checking, we can check whether this Q is empty or not by checking whether front and rear are pointing to the same point. And when it comes to is full, we need to check whether self rear plus 1 equals self front. However, we need to be careful in this case because this one is a circular Q. So front can be at this position and rear can be at this position. So rear plus 1 might be out of the range. And to deal with that, what we're going to do is we're going to take a modulo operation like this. So this one assures that the rear position circles around this Q. Okay, so this is very important, taking this modulo operation. And when we want to check the front item, we just need to check if self is empty or not. If self is empty, we are going to raise a empty Q error. Otherwise, we are going to just return the item at the front position. So this is quite simple. And when we try to dequeue some item, we need to retrieve the item at the front first. And we're going to return this item. And we need to move our front to a new position. So our new position of front is going to be front plus 1. However, we need to make a circle around the list we created, and that's done by this modulo operation. So this modulo operation is the key. in implementing this circular queue. And when you try to in-queue some item, you just need to check whether this queue is full or not. If this one is full, we are going to raise full queue error. Otherwise, we are going to put a new data. Sorry for this, in QX. Then we're going to put this new item where the rear pointer is pointing at, like this. And we need to change the position of rear by adding 1. However, to assure that this one circles around, we're going to take a modulo operation here. So this is what we are going to do. So this is basically how you implement this circular queue using Python, not Python list, but just normal arrays, using these normal arrays. Any questions regarding this implementation? Okay, let's move on. So in the stack class, we talked about how we implement these stacks using Python list and then arrays. And the next topic we talked about was implementing stacks using linked list. And we can do the same thing for queues. So here we're going to implement queues using linked nodes. So let's implement queue in a different way. So this is to make this the previous implementation more effective, efficient. But before we implement our queue class, we first need to define our node class. So this one stores an item and position to the next node. This is what we saw in the last class. And we're going to use this node class to implement this queue class. And the init method is simply none. And we're going to keep track of the rear position to make this operation more efficient. And we need to implement isEmpty method. And to check this, we just need to check whether self.front is none or not. Okay, so that's what we need to do. And to retrieve the item at the front, we need to check whether self is empty or not. If this is the case, we're going to raise empty queue error. Otherwise, we're going to return the item at the front node. So this is quite simple. And in the case of DQ, what we are going to do is, if self is empty, then we need to raise empty queue error. Otherwise, what we are going to do is, let's say there was one front item and next item like this, and we are retrieving this front item. And this temp is going to be the item stored at the front node. And we need to update our front. So this was our previous front node. And after removing this front node, the next front is going to be this one. And to do that, we can just simply assign the next node to the current front. So we are updating our front in this way. And if self front becomes none again, we want to make sure that our rear becomes none as well. So this is to guarantee that our Q is working perfectly. And we're going to return the temp item. So this is how we can implement our isEmpty DQ method. And in the case of InQ, we first need to create a new node having this item. And what we are going to do is we need to care about two cases. The first case is when this Q is empty. And the second case is when this Q is not empty. When this Q is empty, we're going to assign this temp node to both front and rear. Because when there's just one item, front and rear point to the same position. And when there is more than one item inside this queue, what we are going to do is rear.next is going to be temp, and we need to update rear to temp. So this is how we enqueue a new item. Okay. Okay, up to this point, any questions? Oh, hey, are you asking about this? In DQ. Even though you do this, item does not change. So this item is what you intend, okay? And in this case, you can so either of them is okay. So you can put temp into this rear position directly. This one is okay. Or you can assign this value because this one is basically temp. So both are okay. Any other questions regarding this implementation? Cool. And I would like to end this class with SPPP exercise. Here, we're going to talk about applications of queues. So you can use queues to solve various types of questions. And the first question that I would like to give you regarding applications of queue is this one. Open lock question. So what this question is about is you start from 0, 0, 0, 0. So lock is in Korean 자물쇠, and you want to open this 자물쇠 using your password. And you are starting from 0, 0, 0, 0. And then tick your numbers. And when you tick this number, let's say you're ticking the first position, then it could be either 1, or when you tick this one in the reverse order, then it could be 9. And you can tick other positions as well. So anyway, you are starting from 0, 0, 0, 0, and the target is given. And that end means when you reach here, the lock blows. So you just need to stop there, okay? And what you wanna know is whether you can reach this target starting from 0, 0, 0, 0. And there are some dead ends. If this point, if you reach this point, then you are done. You cannot go on. Okay, so that is this problem is about. And you can implement this function using Q. So what you are going to do is you are going to start from this 0, 0, 0, 0 position and tick each value, each position like this. And then in Q, this one, into our Q again. And tick here other numbers. So after this position, let's say you tick this position, and this could be like 1 or 9. So you are going to tick every possible ways and try to figure out whether you can reach target or not. And when you do this, one of the basic things you can do is first, this one is basically string. So you can get one position and you can add 1 or -1 like this. However, ticking 0 in the reverse order is quite tricky. However, let's say we are going to convert this one as int, and then -1. Then if you perform modulo 10 operation, it's going to become 9. So -1 modulo 10 is going to be 9. So you can implement this ticking using this modulo operation. Okay. So these are some tips or hints you can implement this function. So convert this each string into int and tick this value, and then add this value, attach this value to the original string at the moment. All right, so that is some hints. And I'll give you some time, so try to implement this function. And before you tackle this problem, please send me a PPP message. So the returning value of this open log is how many steps you need to take to reach this value. So from this initial position, you need to take 6 steps to reach 0 to 0, 2. And in this case, you just need to take 1 step. And -1 means you cannot reach this position when these deadlocks are given. That's a good point, Chanun. So the returning value is the number of steps to reach this target. Heejun gave me this question. If you just move our front to the next front, then this one, doesn't this one remain in the memory space? And we are using the memory space in an inefficient way. In Python, there is something called garbage collection. And some objects, let's say there is an object, and if nothing is pointing to that object, that means there is no name. Then this one, this object, together with memory space, gets deleted automatically. So in C or C++, you need to free this space on your own. However, Python does it for you. So if there is nothing pointing to this position, then this one gets deleted automatically. And that is called garbage collection. Does this answer your question, Heejun? Because we are running out of time, I'll give you some code templates and you can solve it on your own. First of all, you need to create a queue like this. And what you are going to do is, in queue, the first initial point, 4 zeros. And then here, you are going to add one more thing. So this notation basically means the state and the number of steps together. And you also need to keep track of the visited places. Otherwise, you are going to go from initial point to the next point. And if you take this one in the reverse order, it's going to be the initial state again. And you don't want this to happen. You don't want to visit the same state again and again. So we are going to create these two things, queue and visited list. And what you are going to do is, while this queue has some items inside, you are going to retrieve string and step from this queue. That is done by dequeuing. And what you are going to do is, if this string is dead ends, you just need to continue. There's nothing you can do. Otherwise, what you are going to do is, and another thing you need to do is, if this string matches the target, then you are done. So you are going to return step. So these two things are the basic conditions you need to check. Otherwise, what you need to do is for each position, so let's say this one is 0th position, 1st position, 2nd position, and 3rd position. What you are going to do is first convert this number, convert this string into a number using this int, okay? And what you are going to do is for dx in -1 and 1, so you are going to tick the values, the value at position I, okay? So using the trick I introduced here, we're going to manipulate the number and create new string, new number or string. And you need to check if new string is not in this visited list, then what you are going to do is enqueue this new string together with increase step. Okay, and you are going to append this new string to this visited. So this is basically what you need to do. All right, think about this question on your own, and I'll solve it next time. Let's call it a day. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.